Okay, guys, so today we're explaining a quick little foldable. Is it a function? This should actually be a pretty nice, fun skill for you guys. And I want you guys to write this down, all right? Because it's not written down on yours, write it down. And I apologize for my sappy handwriting. I'm just gonna blame it on Raul for some odd reason. But this is definitely a V. So if you think it's another letter, you're just crazy, that's a V. So it says every X has to have its own unique Y. Also, I wrote down, remember X values, we usually call them sometimes inputs in mathematics, and Y values we associate with outputs. So every X, every input, has to have its own unique Y or output, and that's it. So write that down, and that's the only thing you need to know for this foldable. If it makes sense already, awesome, you're a genius. If it doesn't, it's okay, I'll explain it as we go through it. So in the first flap, we're going to take out a list of points, okay? So I got points here, and this is all we're going to do. We're just gonna check to make sure that every X has its own unique Y. So I look at all the X values first. I don't care about the Y's initially, I just look at the X's. So I got a 1, -2, and 1. Well, I have 2 repeats. I have 2 X values that are both 1 and 2 X values that are both -2. And remember, functions like an equation. So what this is telling me is, hey, if you plug a 1 in to this equation and you show all your work, you'll get -2 as your output. Okay, so I only expect then, if I plug in a 1 again, I should get -2. Is that the case? No, we did some weird voodoo math. I don't know what's going on here. This is screaming not a function. And I'll explain that again. I have another set of repeats, right? You only need 1 repeat that doesn't, provide the same Y, but we got 2 here, so it's definitely not a function because if you plug in -2, they got 0. They plugged in -2 again and they got 2. I don't know what's going on here. So that's not possible, not a function. Second list of points. I'm gonna go ahead and take a look at all of my X values. I got 1, -2, 5, there we go. There's my repeat. Now, because I have a repeat in X's, I have to make sure the Y's are the same, right? Because when you plug in a number into an equation and you solve, you'll get an answer. If you plug in the same number again, you should expect to get the same exact answer. So let's check it. Do they have the same Y values? No. This time they plugged in 1, they got -2. They plugged in 1 again, they got 3. That's just some messed up stuff. Not a function. Simple. Now if we have tables, and again, tables are just like points, but instead of being listed out, they're just stacked on top of each other. We're gonna do the same exact thing. I'm gonna look at my X values. Do I have any repeats? -3, 2, yes, right here. 2 and 2. I got 2 repeats, right? Or 2 repeats. Now it's okay if they repeat, as long as the Y values are the same. So let's take a look. Are my Y values the same? No. This one, they got 8. And the second time they plugged in 2, they got 10. That's just complete madness. Not a function. Okay? If they were to match, and it was just kind of if it was like 2, 8, 2, 8, then yeah, that could be a function because you plugged in 2 again, you got the same answer, that's okay. But if you have 2 different outputs for the same input, no bueno. Let's take a look at this table over here. I look at my X values, 12, 3, 4, 9. So none of these X values repeat. And that happens. Even when you got listed numbers, right? If you're looking at the X values and none of them repeat, well, we can only assume each X value has its own unique Y value. I don't even care about these repeating. I don't care. If none of the X values repeat, we assume that it is a function. We're good to go. And that's it. You walk away, question's done. Let's move on. Function maps. Function maps kind of work the same way. You just got to look a little more closely. So I'm going to look at my X values first, right? We don't care about the Y's right now. Don't look at my X's. I look down the line, I got a bunch of numbers that are all different, right? Which is fine, that's usually how maps work. They usually don't repeat as far as the actual number goes. You need to look at the lines. Does each X value have 1 line coming off of it? Let's see here. 1 line, 1 line, 1 line, 1 line, 1 line, 1 line, 1 line. Each X value has 1 line to a Y value. I don't care if someone goes to the same one, I don't care. Each X value has 1 line coming off of it. This is a function. Done deal, case closed, walk away. Next function map, Venn diagram looking thing. I'm gonna look at my X values. Again, none of the numbers repeat, right? None of these numbers repeat, but when I look at the lines, one line, one line, one line. Ooh, this guy right here has 2 lines coming off of it. And you best believe it does not look like these lines are going to the same spot, right? This -9 goes to -16, and it goes to a 9, right? There's no way you can plug in a 9 into equation and get 2 answers. It's not even going to happen, especially when we're talking about these linear things. So here we go. This is not a function. So because this 1x value had 2 lines coming off of it, this 1x's input had 2 different outputs, not a function. For graphs. For graphs, you guys can write this down. Hopefully I spell it right the first time. I think I did. If not, we'll blame Raul. Vertical line test. So write down vertical line test, also known VLT because we're lazy. And when you do the vertical line test, obviously you're going to have 2 answers. It's either going to vertical line test and it'll say it's a function, or the vertical line test will tell you it's not a function. So you have 2 different outcomes here. And this is all you look for. You're going to draw a bunch of vertical lines. And vertical line test is going to help us when we have graphs. When you do the vertical line test, it'll either tell you, yes, function, no, not a function. And the way we know this is that when you draw your vertical lines, if the vertical lines only touch one time, it's a function. If you have a vertical line that touches more than once, then it's not a function. And that's what we're going to look for. So here we go. And just to help out here, I'm going to use some colors. I'm just going to trace over these things really quick, just so we can see them a little easier. So for my first graph, my goal here is to touch this line with a bunch of vertical lines. So vertical line, only touch one time. I can draw a vertical line anywhere I want. One time, one time, one time, one time, one time. The goal is to try to draw a vertical line that touches more than once. In this case, I can't. I don't care where I draw a vertical line. I can try my hardest. Anywhere I draw a vertical line, it does not touch more than once. Every single one of these lines touch one time. So this one is a function. It passes. Done. This graph looks a little similar, right? It looks like a giant M, right? So if I draw a vertical line here, look at that. It touches one time. If I draw a vertical line here, it touches one time. If I draw a vertical line here, it touches one time. Now, before we go ahead and jump the gun here and say, oh, it's a function, just remember, if you draw one vertical line that touches more than once, it's not. And this happens right along the edges of this M here. If I draw a vertical line going down right down here, notice it runs along the side of this line. That means it touches technically an infinite amount of times. I'm only drawing about 10 dots here, but it touches an infinite amount of times. That's definitely more than once. Not a function. And that's it. If you draw one vertical line and it touches more than once, it fails. Fail, fail, double fail, not a function. All right, next 2 and last 2. We got Batman. Let's see if the big old Batman is a function, yes or no. Well, if I draw a vertical, that's the very first one I would choose. Let's see here. Let's say if I chose this one. Ooh, it touches one time. But, sorry, Batman, if I draw a vertical line here, touches once, touches twice, and actually it happens a lot here on Batman. If I draw a vertical line here, once, twice, he's got a bunch of fails. He fails hard. Sorry, Batman, you are no good for mathematics. You are not a function. Dunzo. Last one. Let's get this little S-looking noodle sideways thing, right? Well, my goal is to try to draw a line that touches more than once. Let's see here. If I draw a line here, touches one time, so far so good. Draw a line here, touches once, touches once, touches once, touches once. Actually, I'm pretty convinced if I draw a line anywhere on this graph, it will only touch one time. I'm sold. It is a function. And that's it, guys. So that's all you got to do. Draw a bunch of vertical lines. If it touches once, it's a function. If you can draw one line that touches more than once, then it's not a function. And that's it, guys. So rewatch the video if you have to. Stay healthy, stay safe, be awesome. You guys have a great day.